All right, semester review time. What I'm going to do in this video is go through each of the problems on the semester review. You can skip ahead or rewind as you wish. I would suggest that you do the semester review on your own and then check the answers that I've given you. And then if you have a question on any of the problems, skip ahead to the video to that problem that you need more of an explanation with. Don't feel like you need to watch the whole video, but just find the problems that you need a longer explanation, and we can go through the ones that you really need help with in class. But this could be a good review as you're preparing those days before the exam when we don't have class. So I'm going to go through the document, and keep in mind I'll go through all of them for accelerated and regular geometry, but once we get to problem 56, that's the end for the geometry review. 57 to the end will be accelerated. So watch the problems that you need. So let's get started going through those problems. All right, first problem, we're trying to find the length indicated. We see that this is a segment addition. So if QR is 11, I know RX is X, so 11 plus X will equal QS, which is 22. So I set up an equation and solve it. I know X has to be equal to 11. Okay, next problem. Same thing, we have this. We can apply the segment addition postulate. QR plus RS equals QS. So if I apply QR, which is 2x plus 17, plus RS, which is 11, that should equal QS, which is x plus 21. And then once I know that, it's just a matter of applying, solving the equation. Combine like terms, I get 2x plus 28 equals to x plus 21. Get x on one side, subtract x. So I get x plus 28 equals 21. And then subtract 28 from both sides, and I get x equal to negative 7. And the problem just asks to solve for x, so we're done. If we wanted to find QR, we'd have to plug that back in to find that solution. Okay. Next, we need to find the measure of the angle. So we're going to need to take out our protractor and measure the angle. So I'll take my protractor here and line it up. And it looks like it's going to be close to, what is that, 56 about. Remember, this is an acute angle, so it's between 50 and 60. If it were an obtuse angle, it'd be 120, it'd be 124. So you have to determine whether it's acute or obtuse and then line it up. Well, let's see what they had. They had 55. You'll be off. You might be off a degree or two depending on how accurate your protractor is. If I would have lined it up properly, make sure to get the vertex right there on the point, it would have been closer to 55. So yeah, 55 is probably the better answer. Okay, but if you're off a degree or two, it's not a big deal. Next, we want to draw an angle with the given measurement. So we'll take out our protractor again. Make sure to line it up, this point on the vertex. Line the line up at 0. And then we want 110. So this is going to be an obtuse angle. So I don't want this 110 because that'll be acute. So I line it up right here. And I can line up my line and then mark the angle up. Oops, undo. Be better if I use my straight edge. Oops. I get my straight edge out. I can line that right up and get a straight line. So I'm having trouble lining this up. But what you would do is just get your straight edge and line it up with the mark. I can use my line tool and draw my angle right there. And I've got a 110 degree angle. Check it. Does it make sense? Yeah, that's an obtuse angle, so that should work. All right. Classify as acute, obtuse, right, or straight. We can see that it is greater than 90. So that would be obtuse. Remember, acute is less than 90. Obtuse is greater than 90 but less than 180. A right angle is 90 degrees. Straight angle is 180 degrees. So keep those terms in mind as you classify angles as we go through that. Next one. Acute right, obtuse, or straight. Once again, this is 90 degrees, so it's got to be a right angle. Draw and label to fit the description. A straight angle, angle IJK. So straight angle is 180 degrees. It looks like a straight line. And I know I've got 3 points, 2 rays. J is the vertex since it's in the middle, and I and K on either side. Name the vertex and sides of each angle. Well, the vertex is point E, and the sides would be ray EF and also ray ED. Notice that E is the beginning point since it's the vertex of the angle. Now we want to find measure of ZIJ. If measure of angle HIJ is 150 and HIZ is 26. So HIZ, let's put that a different color. HIZ will be 26. We want to find the measure of angle ZIJ. So it would be this angle here. So notice we have angle addition. You can apply the angle addition postulate. I want to find that measure. So 26 plus x is equal to 150. Since the two smaller angles add up to the full angle. So just solve for x, subtract 26 from both sides. X should be equal to 124 degrees. Next problem. Our measure of FGH is 23 minus x. So FGH is 23x minus 8. And WGH is 18x plus 12. And then FGW is 20. So let's see. FGW is 20 degrees. Okay, so if we want to find the measure, we can apply the angle addition postulate once again and set up an equation. So FGW, which is 20, plus WGH, which is 18x plus 12, should equal the full angle FGH, which is 23x minus 8. Once we've got our equation set up, we just solve the equation. So combine like terms, 20 plus 12 is 32, plus 18x equals 23x minus 8. Get the x's alone on one side, so subtract 18x. And I get 5x minus 8 on the right side. I'm left with 32 on the left. And then I will add 8 to both sides and get 40 equal to 5x. Divide by 5 on both sides, and I'll get x equal to 8. And I just need to check to make sure that that's all I need to find. So it's find x. It doesn't ask us to find the actual angle measure, so that's all we need to do. And we can check to make sure we did that right. Yes, x is 8. Perfect. Moving on to the next one. Name the relationship. Complementary linear pair, vertical, adjacent, alternate interior, corresponding and alternate exterior. Remember, complementary means that they add up to 90 degrees. Linear pair, they're just an adjacent and they add up to 180 degrees. Vertical angles, they share the same vertex and they're made up of opposite rays, so like angle 1 and 2 here. Adjacent, they share a ray and a vertex. They're right next to each other and they have an opposite ray. Alternate interior, that would be if we have two lines cut by a transversal. The alternating sides of the transversal on the interior of the two lines. Corresponding, that would be the same thing. We have same side of the transversal, same direction in connection with those two lines, both above the line to the left of the transversal. And alternate exterior, that would be if they are alternating sides of the transversal and on the outside of those two lines. So which one do we have here? They're alternating. Here's our parallel lines. Here's our transversal cutting through those two. They're alternating sides of the transversal, and they're on the exterior of these two parallel lines. So this would be alternate exterior. Now we want to find the measure of angle B. I know this is 293, plus this part is B, plus this is 29. That gives me a full rotation. So if I add all three of those angles up, it gives me 360 degrees because that's how much in a full rotation. So once I've set up my equation, I can combine like terms. This is going to give me 322 plus B equals 360. And if I subtract 322 from both sides, I get B equal to 38. And that would be 38 degrees, if you want to be specific and precise. Next, we want to find the measure of angle X. So first of all, I need to see the connections. I see I have two lines that are parallel, and I've got a transversal cutting through here. So what is the connection between these? Well, I see that this angle here and this angle, they are alternate exterior angles, and alternate exterior angles are congruent. So if alternate exterior angles are congruent, I can set up an equation that shows that. So 3x plus 1 would be congruent or equal to 124. I have an equation, I can solve it. I subtract 1. 3x is 123. And divide both sides by 3. I get x equals 41. Once again, just ask for the value of x. So that's all we would need to find for that one. Okay. 14. Write the statement given as indicated by the marks on the diagram. Well, is BD congruent to BC? BD and BC. Well, it looks like they're the same. But these tick marks are the same, so that would show that yes, those would have to be congruent. You can only trust what the diagram gives us. Now let's get into transformation. Translate. That means we're moving the figure. It's a rigid transformation, so it maintains same shape and size since all the points are moving that same. So xy, arrow x plus 6y plus 5. What's happening? Well, they're going right 6 on the x-axis, and adding 5 on the y-axis means we're going up 5. So if I have a graph, I can just move all my points right 6 and up 5. This would be k prime. R goes right 1, 2, 3, 4, 5, 6 up 1, 2, 3, 4, 5. R prime. T prime goes right 6 up 5. So I got T prime. 1, 2, 3, 4, 5, 6. And U prime. And then I could connect those to form my quadrilateral. If I did it correctly, it should appear to be congruent. since all the points are moving right 6 and up 5. Keep in mind that you could also create a table, x, y, and then list the coordinates, and then right next to it or below it we could say x plus 6, y plus 5. So we could list out all our coordinates for k, r, t, and u, and then figure out what k prime, r prime, t prime, and u prime would be based off of the rule. So once you figure out the original coordinates, you can just apply the rule, adding 6 to my x's. So I could have -4 plus 6 is 2, -1 plus 6 is 5, -5 plus 6 is 1, and -3 plus 6 is 3. Then do the same with the y coordinates. 0 plus 5 is 5, -2 plus 5 is 3, -3 plus 5 is 2, and -5 plus 5 is 0. That would give you the new coordinates, and you could plot those on the graph in the same manner. So pick and choose whatever method you prefer, and then go with that. All right, next one. We're going to reflect across the x-axis. So it's important to know which one's the x-axis. And keep in mind reflections. Those reflect perpendicular to that axis and stay the same distance away. So J is right on the axis, so J prime will stay on the x-axis. L is below the x-axis 1 unit, so it will reflect up 1 unit. M is 1, 2, 3, 4 units above. It will reflect 1, 2, 3, 4 units below that axis. And connect the dots, and that's how it would be. Keep in mind we can do that the same way. The rule for reflecting across the x-axis, if it reflects across the x coordinate stays the same, but the y coordinate becomes the opposite. So we could do that the same way we did the other one, is we could list all our x and y's in a table, and then just change the y coordinate to its opposite for M, J, and L. So if I list the original coordinates for M, J, and L, I keep the x coordinates the same for M prime, J prime, and L prime. I just flip the y coordinates to their opposites. Okay. Next, let's take a look at a rotation. Question 17. Rotate 90 degrees counterclockwise about the origin. So once again, if we know what's going on, a rotation about the origin counterclockwise means we're going opposite the way the clock turns. It's 90 degrees, so each point will move 90 degrees. So this is 2 units. Right angle go right here, so U prime. V. Now here's where it gets a little bit trickier. So if we can't figure out exactly where it lines up, and we might need to create the rule for this one. So if you remember the rules for 90 degree rotation is XY arrow. Well, what happens? Well, the y's switch and become opposite. So this coordinate was 0, 2. It now becomes -2, 0. So what was in the y coordinate comes to the front and becomes the opposite, and the x stays the same. Okay, so I made out my table for A, V, U, and K, listed my original coordinates, and then I took the x coordinates, the original x coordinates, and put those on the back for the new y coordinates. And the original y coordinates moved to the front. They're my new x coordinate, and I made them opposites, 3 and -3. Notice they all switched to their opposites. If these were negatives, they would become positive. So then I would graph these, -3, -4. This would be A prime. V prime would be -4, -2, which I had. I wasn't quite sure since I just eyeballed it up and made, once I found the exact coordinates, I see it was right on. So U prime is -2, 0. K prime is -1, -3. We can connect the points. Oops. And go from there. So we see that it rotates 90 degrees. Each point rotates 90 degrees. You can see that right angle. You could use your compass or your protractor to measure out the angles, and use a compass to figure out the distance, mark that distance off. That would be another way to do that. Down here are the rules. So this is a 90-degree counterclockwise, XY arrow opposite YX, 180-degree rotation. The X and Y's both become opposites. 270, and these are all counterclockwise, is XY arrow Y opposite X. So you might want to remember those rules if you want to use the coordinate rules for those. Now let's write a rule to describe the transformations. You can see that this one's just moving. Okay, so this would be a translation. It's moving to the right 1 and up 1. So you could say right 1, up 1. And if we want to use arrow notation, be a little bit more precise, we could say, well, we start XY, and it becomes X plus 1, Y plus 1. So either way works, but you want to make sure you also give not only translation, but a direction, whether it's right or using the arrow notation. Okay, and the other thing to keep in mind is that pre-image, image. We know the image always has the prime notation. All right, this next one, we can see it's not translating since it's a different orientation. We can see that it's not just a rotation, but it's a reflection. And I can kind of see where that reflection line is because X, halfway between those 2 points, halfway between these 2 points, Q and Q prime, D and D prime, and L prime are on the line. So when they're on the line, we know the line has to go through that point. So we could say reflection, and we need to describe what it's reflecting across. So this is reflecting across the red line that I drew on there, and that line we would describe as x equals -1, because it's the line that goes through the x-axis at -1. Here we see that the orientation changes. We see now that it's rotating. And if I connect the points, I see that forms a right angle. So we can say it rotates, and we can describe this in 2 different ways. We can say it's a 90-degree rotation, and that would be counterclockwise. And the other way we could describe it is if it went clockwise. So if it's 90 counterclockwise, the complement to that would be 270 clockwise. Okay, so either one would work. Just keep in mind if it were multiple choice, you'd have to pick and discover which one of those answers is on there. All right, so going back again to transversals and lines, we want to label these. We talked about what these terms are. I think last time we didn't talk about consecutive interior. So just keep in mind with consecutive interior, we have 2 angles that are on the same side of the transversal, and they're both interior angles. So here, this choice would be they're both on the same side of the transversal and both above these 2 lines. So we'd say those are corresponding angles. Next, if we want to find the measure of the angle indicated, we first need to find the relationship between the 2 angles. So 132 and x, I would say those are a linear pair. And if they're a linear pair, they're supplementary. Supplementary, they add up to 180. Linear pair is 180 degrees. So 132 plus x equals 180. So if we subtract 180 minus 132, we see that there are 48 degrees left over for angle x. Next one, we want to solve for x. We see that these are parallel lines. That gives us a clue. Next, we need to determine what kind of angles these are. These two angles are both on the same side of the transversal, and they're both interior angles. So we call these consecutive interior angles. Consecutive interior angles are supplementary. So if they're supplementary, they add up to 180 degrees. So 26x plus 2 plus the other angle, which is 32x plus 4. Those two angles will have a sum of 180 degrees. So once we set up our equation, it's just a matter now of solving that equation. So combine like terms, 26x and 32x gives us 58x, and 2 and 4 give us 6, still equals 180. Subtract 6 from both sides, we get 174 equals 58x. And we divide both sides by 58, and we get x equals 3. And all we were doing in this problem is solving for x, so our job here would be done. Next, we want to find the measure of the angle indicated in bold. That would be this angle. So we find the relationship between the two angles. These two angles are alternate interior angles. Alternate interior angles are congruent. So if they're congruent, their measures are equal. So 21x minus 5 is equal to 19x plus 5. So solve for x. Get the x's on one side. Subtract 19x from both sides. I'll get 2x minus 5 equals 5. And then add 5 to both sides. So 2x equals 10. And then I'll divide both sides by 2 and get x equals 5. But that isn't what we need. We want the angle in bold. So we'll take 21 times 5 and subtract 5. 21 times 5 is 105 minus 5. 105 minus 5 is 100. So 100 degrees would be this angle measure here. It would also happen to be that angle since those are congruent. Now we want to find the angle that makes lines U and V parallel. Well, if they're going to be parallel, we know connections between these. If this is 119, this is 119. And this one would have to be, 61, linear pair. And then I could translate all these angles down here. 119, 61, 119, and 61. So this angle would have to be 119. The other way we can figure that out is these two angles are alternate exterior angles. Alternate exterior angles are congruent when lines are parallel. Okay, next one. Find the measure to make the lines parallel. So if they're going to be parallel, I know this angle and this angle will correspond. So corresponding angles are congruent. So if corresponding angles are congruent, I can set up an equation that makes their angles equal. So x plus 52 would equal 45. Solve for x, subtract 52 from both sides, and x will equal negative 7. We're just finding the value of x, so that would be all we would have to find there. Midpoint. To find the midpoint, I can just find the average of the x coordinates, x1 plus x2, and divide them by 2. And I can find the average of the y coordinates, y1 plus y2, divide those by 2. Or if I have a graph, I can just look on the graph and find midway point. So I know this is a distance of 1, so halfway between there. So if we go halfway, find that point right on there. So I can see that this coordinate will be, if this is 1, 1.5, it's halfway between 1 and 2 is 1.5. And then if I find the halfway point between my y coordinates, this is 0, this y coordinate is 3, half of 0 and 3 is 1.5. So 1.5, 1.5. To do that algebraically, add up the x coordinates. So 1 plus 3, or 1 plus 2, rather. Divide those by 2. And the y coordinates. This one is 0, this one is 3. And we should get the same thing. 1 plus 2 is 3, divided by 2 is 1.5. 0 plus 3 is 3, divided by 2 is 1.5. Distance. So distance, there's a fancy formula that you could try memorizing or just remember distance. We can just do a squared plus b squared equals c squared to use the Pythagorean theorem. So if we create ourselves a right triangle, so I'm going to go over and directly up, got a right triangle, and I've gone over 2 units, up 1, 2, 3, 4, 5, 6, 7, 8, 9 units, and that would mean opposite is the hypotenuse. This would be c. So 2 squared plus 9 squared equals c squared. 2 squared is 4, 9 squared is 81. That equals c squared. So 85 is c squared. And then take the square root of 85 to solve for c. At this point, I could leave it as the square root of 85 because I can't simplify it any further. The only thing I can divide 85 by is 5, and 85 divided by 5 is 17. So square root of 5 times square root of 17. Neither of those is a perfect square, so we couldn't break it down any further. This would be as simplest as it could get. If I wanted to approximate it and take the square root of 85, I could do that. The square root of 85 is approximately 9.22. That would be an approximation. But you can just leave it as the square root of 85 because that's its exact value. Slope-intercept form. Slope-intercept form, you remember, is y equals mx plus b. If it goes through a point and it's parallel, parallel means it has the same slope. The slope here is negative 7/4. I know the slope of my line will be negative 7/4. So that's going to be my slope. I just got to find the b, the intercept. And I don't know that right now. All I know is it goes through negative 4, 5. So I can start off with my equation, y equals m, negative 7/4, x plus b. I can solve this graphically if I want, otherwise I can do this algebraically. I'm going to show you how to do it algebraically. So I have an xy coordinate, so I can plug in the x and the y. So y is 5, and the x is negative 4. Solving it algebraically gives you the exact value. Sometimes solving it graphically gets difficult to find the exact value for the intercept. So that's why I'm showing you the algebraic method here. Then we simplify and solve for b. So negative 4 times negative 7 is 28. Divided by 4 is 7 plus b. Then I solve for b, so subtract 7 from both sides. Negative 2 is b. So I found my slope and my intercept. My equation y equals negative 7/4x minus 2. All right. Next problem. Take a look at doing slope-intercept once again. But we're doing a line perpendicular. So keep in mind when lines are perpendicular to each other, their slopes are opposite reciprocals. So in this line, the slope is negative 3. So the opposite reciprocal of that is 1/3. So we can take our equation y equals 1/3 x plus b and solve for b by plugging in our x and our y values of this coordinate that it goes through. So it goes through, y is -2, x is 3. Substitute those in there and solve for b. So 1/3 times 3 is 1. And if we solve for b, we subtract the 1, we get -3 as our b value. So y equals mx plus b, 1/3 x plus b minus 3. Classified by angles and sides. So remember, by angles, it's either acute, right, or obtuse. And if it's acute, all the angles are acute. If it's right, there's one right angle. If it's obtuse, there's one obtuse angle. And we can classify by sides. So it's isosceles, scalene, and equilateral. So scalene means none of the sides are the same. Isosceles means 2 of the sides are the same. Equilateral means 3 of the sides are the same. So in this case, what do we have? We have angles are all less than 90, so it's acute. 2 sides are congruent, so it is isosceles. Sketch an example. So sketch an equilateral triangle. Well, I know all 3 sides should be the same, so I'll mark my diagram that shows that they are the same. Find the measure indicated. Well, I know that that each triangle has a sum of 180 degrees. So if we call that x20 plus 128 plus x equals 180. So if I simplify those, I get 148 plus x equals 180. So I subtract 148 from 180, and I get x equals 32 degrees. Same thing for the next triangle, solve for x. So I know that I have 3 angles in a triangle, 90 plus 55 plus 41 plus x. And those will add up to 180. So the sum of the angles in a triangle is 180 degrees. So 55 plus 41 is 96, plus 90 is 186, plus x equals 180. So subtract 186 from 180, x is -6, which would make this angle 35, plus 55 plus 90 is 180. But all we want is x for the solution here. Find the measure. Well, I know this one is the one I need to find. I have one angle but not the other one. If I can find this angle, I can eliminate it. So I know these 2 angles are vertical, so these will be the same. So 69 plus 45. If I subtract that from 180, I can find that third angle. So 69 plus 45 is that 114? So 180 minus 114 is 66 degrees. So this one's also 66. Plus 46 is 112. So subtract 180 minus 112. And that will give us 68 degrees for that angle. And that should be the measure of the angle we're looking to find. So you might need to find other triangles and apply relationships to find the missing angle. All right, so here we need to find this angle up here. So if we can find this one, be vertical, it'd be the same. So 50, this one's 50 because it's vertical also. Got a triangle. 90 plus 50 is 140. Subtract that from 180, I get this one 40. Vertical angles, this one has to be 40 as well. All right, next one. We're trying to find this angle here. There's 2 ways I can find it. One way, if this is 60 and 50, that's 110. Subtract from 180, this has to be 70. These two are a linear pair. 70 plus 110 gives us 180. So this angle has to be 110. The other way to know that is the exterior angles going to be equal to the sum of the two non-adjacent interior angles. And we'll apply that later on, but two ways we can figure that out. So 110, because these two add up to 110, or we find the sum of the angles in the triangle, and these are a linear pair. So now in this problem, I know 21x is the exterior angle, and I know that it's going to be equal to the sum of the two non-adjacent interiors. So 21x will be equal to 74 plus 9x minus 2. And I can solve that equation down. So this will be 72 plus 9x equal to 21x. Subtract 9x from both sides. I get 12x equals 72. Divide both sides by 12. X will be 6. Let's name the corresponding side or angle. We know when triangles are congruent, all the corresponding sides and angles are congruent. And we can tell angle B is the angle we want to find. B is the first letter in this congruent statement, so that's going to match up with angle D. So angle B and D will be congruent. Same way that C and T would be congruent, D and S would be congruent. Side CD would be congruent to side TS. I could label all the corresponding parts if I wish to. Okay, but we can tell it all from the congruence statement. Match them up from there. Okay. Let's write a statement that indicates the triangles in each pair are congruent. So start with one of the triangles. Triangle, let's say STU. I'll just start off with this triangle here. I need to match it up with the other triangle. It's congruent to triangle. You know, STC, CTS, how do we name it? Well, S is the first one we named here. S is congruent to angle S in this one. And then we did T, which is 2 arcs. 2 arcs is T for that one. And then U is 3 arcs. C is 3 arcs. So we'd say angle STU is congruent to angle STC. That would be our congruence statement. It shows that they are congruent, and we can match up all corresponding sides and angles from there. Let's tell if these triangles are congruent. So the only information we have is that this side is congruent to this side, and this side is congruent to this side. We know by the reflexive property they share a third side. So you'd say yes, they are congruent. How do I know? Side, side, side congruence lets us know. Remember, the other ones we know are side, angle, side, angle, side, angle, 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 side, and hypotenuse leg with a 90-degree triangle. So those are the congruent statements that we've looked at. This one in particular is SSS. So now this question asks what other information is required in order to prove by angle, side, angle. So I know I have one angle already. And looking at the diagram, I know I've got vertical angles congruent here. So the side would have to be the side in between the two angles. So if these are my two angles, I'd have to know this side here. So I'd have to know IQ is congruent to PQ. Would be the other required information for that one. Next, we want to find the value of x. Since all three angles are congruent, it's an equilateral triangle. And I know in equilateral triangles, all sides are congruent. So all sides would be 9 in this case. And x would be 9. Equilateral triangle again. So if all sides are the same, all angles are the same. So x would be 60 degrees. Here we have an angle bisector. And if angle 1 is 5x plus 3, and angle 2 is 6x minus 1. Then I need to find measure of angle x. Well, if it's an angle bisector, PQ splits the angles in half, so they're equal to each other. So 5x plus 3 would be equal to 6x minus 1. Then I'd solve for x, so let's get the x on one side, so subtract 5x from both sides. Add 1 to both sides, x would be 4. Here all the angle bisectors are intersecting at point P. So recall when we have an angle bisector, when that happens, we've got the incenter. So when I have a circle, or when that incenter, I could draw a circle inside the triangle. And if I'm able to do that, that means PR, PT, and PS would all be congruent. So P would be the incenter. That's where all the angle bisectors meet. Okay, so PS is 3, AP is 7. We want to find AS. Luckily, those form a right triangle. So A, B, and C. So we can use Pythagorean theorem, 3 squared plus B squared equals 7 squared, since 7 is the hypotenuse of that right triangle. So 9 plus B squared equals 49. Subtract 9 from both sides, B squared is 40. And take the square root, so B would be square root of 40. And I can break 40, or square root of 40, into square root of 4 times the square root of 10. As I try to simplify it down, square root of 4 is 2. I can't break the square root of 10 down any further, can't take any perfect squares out of it. So B would be exactly 2 times the square root of 10. Or if we wanted to approximate it, we take 2 times the square root of 10, and 2 times the square root of 10 is approximately 6.32 to the nearest hundredth. So either one would work as we go through that one. The answer key listed as 6.32, but if you want to leave it exact as 2 times square root of 10, that would be all right. Here we have the angle bisectors intersecting again. So once again, we can draw that incenter in there. And if we can draw the incenter, that means we can draw the circle inside of the triangle at point P. And that means that these segments are all congruent. If VF is 3, VP is 4, we want to find PG. Well, PG is down here. Well, PG would be the same as PE, or PF rather. So if I've got that triangle, VF is 3, PV is 4, I just need to find FP. So once again, I can use Pythagorean theorem. 3 squared plus B squared equals 4 squared. So I get 9 plus B squared equals 16. Subtract 9 from both sides. B squared is 7. So B would be the square root of 7. There's no factors I can take out of that, so square root of 7 would be the exact solution. If I wanted to approximate it, B would be approximately 2.65. And since FP is the same as that, PG would be the same as well. Dealing with the angle bisector again, QSR. This whole angle is 38 degrees. We want to find the measure of angle 1. So if it's an angle bisector, it's split in half. So measure of angle 1 would be 19 degrees, since it's half of QSR. Here we have a median. Remember, median goes from vertex to midpoint on the opposite side. So if it's going from vertex to the midpoint, I know that S is the midpoint. And SI would be congruent to SJ. Well, if SI is 2, means SJ is also 2. So JI would be equal to 4, it'd be the full length of that. Here we have the medians again. So TV would be congruent to RV. TW is the median, so RW be congruent to WS. In this case, we see that EW is 9. We want to find TE. Well, keep in mind that point E is the centroid. The point where the medians meet in the triangle is known as the centroid. It has that special relationship. So we know in the triangle that centroid, the point where all those medians meet, we have that special relationship. So the centroid to the endpoint, or to the vertex, is going to be double the distance from centroid to the midpoint. That's true for all of the medians. This is double this part. So this little part is a third of the full length of the median. The longer part is 2/3. So if this is a 9, this part will be double. TE would be 18. So if you remember that relationship, you can find out the other measurements there. Next one, the medians are here again. So point B is the centroid. And now we've got some expressions. YT is the full length. YT is 4x plus 5. And BT is x plus 4. So it might be helpful to just write an equation first of all. YT and BT. How can we make them equal? Well, if I'm looking at BT here, I know since it's the centroid, this segment is divided into this part and this one. So BY is double BT. So what do I have to do to BT to make it equal to YT? Well, YT is the full length, so I need to triple it. So if I triple BT, that will make it equal to YT. Once I have that figured out, I can just fill in my equation. 4x plus 5 is equal to 3 times BT. BT is x plus 4. So now that I have that set up, I can distribute 3x plus 12 equal to 4x plus 5. The x terms alone, so subtract 3x from both sides to get x plus 5 equals 12. Subtract 5 from both sides, x equals 7. That's all I need to find is find the value of x. BT would be 11. YT would be 28 plus 5, 33. So yeah, this would be 11, 22. It all adds up to 33. We did our math correctly. Now finding the coordinates of the centroid. Remember, the centroid is formed, it's the point of concurrency where all the medians meet. Remember, a median goes from vertex to midpoint on the opposite side. So if I'm trying to find that point, let's just start with going from A. So I first need to find the midpoint of the opposite side. This is 1, 2, 3 units over, so go 1.5 units. And we'll connect that line. Don't want that thick of a line, we'll choose a thinner line. Okay, and use a straight edge to make it as precise as possible. Next then we'll find the midpoint from B to the opposite side. AC Well, it goes vertically 1, 2, 3 units. So if I just count 1.5 units up, I can find that point as well. And if I get my line again, oops. And really all we need to find is 2 of the medians. But if we want, we can find all 3 of them. 3 units up, so go up 1.5. And make sure that we did it correctly. Connect that, they all should meet at the same point. And we see that that point is right here is the centroid at -1, -2. Now we want to determine if these 3 sides can form a triangle. Remember, when we're forming a triangle, we need the 2 smaller sides to be longer than the 3rd side. Otherwise, it won't form a triangle. If these 2 sides aren't longer than the 3rd side, there's no way we can form a triangle. So they need to be just slightly longer so that we can form that triangle. So if we have 11 and 10, 3rd side is 23, will we form a triangle? 11 plus 10 is 22, and 22 is not greater than the 3rd side. So always pick the 2 smaller sides. We can try all the sides. 23 plus 11 is greater than 10. 23 plus 10 is greater than 11. But if you just start with the 2 small sides, that's the only one you need to check. So we see that if this side were 23, if we had 11 and 10, there's no way they would meet as a triangle. So no. Find the ranges for the possible measures of the 3rd side. Well, keep in mind if this side is 10, this one were 7, the other one would have to be just slightly greater than, well, if it were 3, it wouldn't form a triangle, so it'd have to be a little bit greater than 3. So the value would be have to be larger than 3. And in the same way, if we had the 2 sides, let's say we had 7 and 10 also stacked together, and our 3rd side was the longest side. Well, we know if the long side was 17, they'd be stacked on top of each other. So this side would have to be a little bit shorter than that. Whoops. A little bit shorter, so that we could find the last side. I guess I lost my drawings. Anyway, so we'd have to have just slightly smaller than 17 if this were 10 and 7. So if we add the 2 sides up, that gives us the one end of the spectrum. So it has to be less than 17, the 2 sides added together. But it also needs to be greater than that 3rd. If we subtract let me start over. If I subtract the 2 sides. So let's call this A and B. So the range for those sides is got to be between greater than the difference, but less than the sum of the 2 given sides. Now, taking a look at the angles, we can figure out the relationship between the sides, shortest to longest. Well, the shortest side will be opposite the smallest angle. So DE, next smallest would be EC, followed by DC. So we can always tell across from that opposite side. If we order the angles from smallest to largest, same thing applies. So the smallest angle will be opposite the smallest side. So angle F, followed by angle H, and then angle G. Alright, so that is the end of the geometry semester review. Feel free to go back and review any of those problems as you need. From here on out, I will go through the accelerated review section that is different from the regular geometry. So if you are an accelerator, you can pick and choose some of these that you need to take a look at. First of all, we want to state if the polygons are similar. If they're similar, all the angles are congruent, and the sides should be in the same ratio. So I can see that I have congruent angles. I just need to show that corresponding sides are proportional. So I match them up 20 to 24. Do they all have the same ratio? Should be equal to 12.5 to 15. And I've got another 12.5 to 15. And then the fourth side is a ratio of 30 to 36. So if I simplify all these, they should have the same ratio. So we can divide these by 4 and get 5 over 6. Let's see, 30 to 36, we can divide those both by 5. Or no, 6 rather. 30 divided by 6 is 5. 36 divided by 6 is 6. We get 12.5 and 15. Are those the same ratio as 5, 6? Let's take a look. Well, I've got this pesky decimal in the numerator, so I can change those by doubling them, so multiplying them both by 2. So 12.5 times 2 is 25. 15 times 2 is 30, so I've got 25 over 30 for both of these. And I see that I can divide these both by 5. 25 divided by 5 is 5. 30 divided by 5 is 6. So they all have a 5 to 6 ratio, so all the sides are proportional, and all the angles are congruent. So yes, polygons are similar. All right, next one. Two polygons are similar. Find the scale factor of the smaller to the larger figure. So I need to find a ratio of smaller to larger. So I match up corresponding sides. So 7 to 14 should be similar if I chose 4 to 8. And if I simplify either of those fractions, I get 1/2. So scale factor will be 1 to 2. Now we know that two polygons are similar. We want to find the missing side length. So we'll just call this one x. X matches up with 25. In the same way that 42 to 35. So if I set up a proportion, I can set it up and solve for x. So I know cross products are equal. So if I multiply both sides by 25, so 42 times 25, and dividing by 35, I can multiply by 35 to eliminate that on the right side. So I know 35 times x, the cross product is equal to the cross product of 42 and 25. 42 times 25 is 1050. And I divide both sides by 35 to get x by itself, so x would be 30. Okay. Next one. Solve for x. Two polygons are similar, so same thing. We want to find x. So 2x minus 7 matches with the side that is 30. The same way that I can choose any of these other sides, I'll choose 3 and 18 because those are integers, make it easier to do our multiplications. But I just need to match up corresponding sides. So 2x minus 7 is the smaller one, goes to the bigger one, smaller to bigger. So we just multiply cross products times 18. Keep in mind that this is quantity. Multiply by 30 to eliminate the denominator on the left. So I get 36x minus 126 equals 90. Add 126 to both sides. I get 216 equals 36x. Divide by 36. X is, I believe it is 6. Let me double check. Yeah, so x would be 6. It just asks to solve for x. We don't need to find the side length. Now, we need to state if the triangles are similar. If so, state how we know and complete the similarity statement. So keep in mind, triangles are similar by angle similarity, side similarity, or side angle side similarity. So if we can prove by one of those methods, we should be good. So we don't have any of the angles, so we're not going to be able to use angle or side angle side. So we're going to need to look to prove by side. So let's match up corresponding sides and see if they are proportional. So I'll start with the smaller triangle. RT is 25. That's the smallest side, so it should match up with the smallest side in the other triangle, 35. Should be equal to, the next smallest is 30 and 42. And then those should match up with the largest sides, 35 and 49. And let's simplify those, see if they're all in the same ratio. You can divide these both by 5. 25 divided by 5 is 5. 35 divided by 5 is 7. 30 and 42. It's going to be divided by 6. 30 divided by 6 is 5. 42 divided by 6 is 7. 35 and 49 can both be divided by 7. 35 divided by 7 is 5. 49 divided by 7 is 7. So by SSS, side similarity, we can complete the similarity statement and state that triangle UVW will be similar to triangle UV was the middle side. So the middle side here is ST, so TS, since U started on the side with the shorter side, T starts from the shorter side, so TS, and that would leave R. Let's double check to see if that makes sense. SR and VW are the longest sides, so that should be correct. And looks like it matches up there. Next one, find the missing length. Two triangles in each pair are similar. So we can set up a proportion. Let's call this one X. It's the hypotenuse, or what appears to be a hypotenuse. It would be the longest side, either way. So let's say X to 10 is the longer side. In the same way that 30 is proportion in the same ratio as 6. So multiply both sides by 6. Multiply both sides by 10. Cross product, say 6x equals 300. Divide both sides by 6. X is 50. Check it to see if it makes sense. 50, longest side, longer than that one, seems to make sense. And we check our answer, it's right. Same thing, solve for x. So match up corresponding sides. So 11 is the longest side along with 22, and then 5 to 2x minus 6. So to solve this equation, we can multiply both sides by 22. Cancel out the denominator on the left. Multiply both sides by 2x minus 6 to cancel out the denominator on the right. And then we can finish our equation. Distribute. 11 times 2x is 22x. 11 times negative 6 is negative 66. And 5 times 22 is 110. Add 66 to both sides. I get 22x equals 176. Divide both sides by 22. Check my math here. So 176 divided by 22 is 8. So x would be 8. which if I checked it, 8 times 2 is 16 minus 6 would be 10. Should be double that. Here we go, we got another similarity problem. We know that this line is parallel to this one, so we know the sides will be proportional since we have similar triangles. We've got angle similarity since we've got corresponding angles congruent. And we know that the third angle is shared by the reflexive property. So 8 to 12, in the same way that x will be similar to 27. Solve the proportion, multiply both sides by 27, multiply both sides by 12. So 8 times 27, 216, equals 12x. Divide both sides by 12. We get x equals 18. Moving along, next one. We've got two lines that are split by three parallel lines. Even though we don't have triangles, we know they're going to be split proportionally. So 15 to 12, in the same way that the other side is split 20 to x. So solve this proportion, multiply both sides by 12. Multiply both sides by x. We eliminate our denominators. So 15x equals 20 times 12 is 240. Divide both sides by 15. 240 divided by 15 gives us 16. So 16 would be the missing length for that one. Here we go. Here we have that side splitter. So in this case, we have the two angles are congruent. We have this angle bisector. So the sides are split proportionally. So 15 to 9, same way that x to 12. So we solve this, multiply both sides by 12. 15 times 12 is 600, or 180 rather. Whoops. Multiply both sides by 9, we get 9x. Divide both sides by 9, and we get x equal to 20. So keep in mind when we have this angle bisector in the triangle, it splits these sides up proportionally. Now we have M, N, and P are the midpoints of the sides. So name a segment parallel to the one given. So we want to name a segment parallel to CE. Well, if these are midpoints, we know we have this special property, and we know that MN is going to be what's known as the mid-segment. We know the mid-segment is going to be parallel to that third side. We know it would also be half the length of CE as well. But all we're asking for right now is which side is parallel. Now when we're finding the missing length, I see that Q is a midpoint, R is a midpoint. So QR is the mid-segment of the triangle, meaning that it's parallel to HJ. And QR would be half of HJ. So HJ would be 20. Once again, WV is the mid-segment. So these two lines are parallel. I know it's the mid-segment because W is the midpoint, V is the midpoint. So if I'm trying to find a connection between MK and WV, in order to make them equal, what do I have to do? Well, I need to double WV. So if I take what MK is, it's x plus 18. And I need to double WV, which is x plus 12. Now I've got an equation I can solve for x. So I distribute x plus 18 will be equal to 2x plus 24. Solve for x, so subtract x from both sides to get 18 equals x plus 24. Subtract 24 from both sides, x is negative 6. You think, well, that's an odd value. I know distances aren't negative, but keep in mind that's just x. If we were to put it back in, negative 6 plus 12 is 6. Negative 6 plus 18 is 12. This side is double that one, double the mid-segment. So that should be correct. Finally, we'll wrap up with some review on matrices and using transformations with matrices. So just a quick overview: when we're adding matrices, we just add the corresponding parts. So negative 2 plus 6 is 4. Negative 6 plus negative 6 is negative 12. So matrices will be the same size in that case. Let's see. Jump. Dilating. When we dilate, we got a scale factor of 5. So we just multiply everything in the matrix by 5. So 5, negative 5, 0, and 25. Now multiplying two matrices together. So keep in mind when we multiply them together, I'll show you the answer right away and I'll show you how it works. We're going to multiply through. So I'm going to multiply this one, the row times this column. So negative 6 times 0 is negative, or 0, plus, move to the next one, negative 2 times 3 is negative 6. And 0 plus negative 6 is negative 6 in the upper left. We stay in the same row and move to the next column. So negative 6 times 2 is negative 12. And negative 2 times negative 5 now is positive 10. Negative 12 plus 10 is negative 2. Then we move down to the bottom. Negative 1 times 0 is 0. Negative 1 times 3 is negative 3. Or sorry, got to move over. So negative 4 times 3 is negative 12. We add those up, that gives us negative 12. Stay in the bottom row, go to the final column. Negative 1 times 2 is negative 2. Move over, negative 4 times negative 5 is positive 20. Negative 2 plus 20 is 18. So that's how we multiply matrices. Now finally we finish up showing how we can use matrices to do our transformations. Let's just say that we have our translation is right 1 unit. Remember, these are the xy's of our, let's call this triangle ABC. These are the x's on top, the y's on the bottom. So if I'm translating 1 unit right, I'm just going to add 1 to all my x values. And I'm doing nothing with my y values. So my image now, A prime, B prime, C prime, I can just quickly add those up. 1, 5, 4, 3, 5, 3. And that would be the image. You can then graph both of those and see what happens. So we have 0, 3, 4, 5, and 3, 3 as our points. New points 1, 3, 5, 5, and 4, 3. Looks like our points are labeled a little bit differently. This one is L, K, W. So this would be L prime, K prime, W prime. Okay? A dilation of a half. So if we're dilating by a half, we're multiplying every coordinate by a half. So I can multiply everything in there times a half. So a half times 2 is 1, 1.5, 2, 2.5, negative 1.5, 0.5, 0.5, and negative 1. So this will give us our image, and if we graph them, that's how it would look like. And it looks like if we label these 2, negative 3 is H, 3, 1 is C, 4, 1 is I, 5, negative 2 is B. So this would be H prime, C prime, I prime, and B prime. So remember, using the matrices, we can find the coordinates a little bit quicker. Reflection across the y-axis. When we reflect across the y-axis, we're going across this line. And so our x coordinates are changing, but our y coordinates stay the same. So we multiply a reflection matrix. We know the x are going to become opposites. That's why we have a negative 1 up here in the x row. But our y's will stay the same. So then once we multiply, we just go through that process, and we multiply negative 1 times 0 is 0, and 0 times negative 5 is 0, so we have 0 up top. Move to the next column. Negative 1 times negative 1 is 1. 0 times negative 4 is 0, so we have 1. Negative 1 times 2 is negative 2, plus 0 times negative 1. Keep us at negative 2. Negative 1 times 4 is negative 4, plus 0 times negative 5 is still negative 4. And then go to the bottom row. 0 times 0 is 0. 1 times negative 5 is negative 5. So we notice that our y's stay the same. 0 times negative 1 is 0. 1 times negative 4 is negative 4. So 0 times 2 is 0. 1 times negative 1, negative 1. 0 times 4 is 0. 1 times negative 5 is negative 5. So this gives us our new coordinates, and we can see what those would be. 0, negative 5 is G. Negative 1, negative 4 is B. 2, negative 1 is U. That's P. So G prime, B prime, U prime, and P prime. So keep in mind, you don't have to use the matrix for this. Maybe you're more comfortable just reflecting everything. No, you have to change all the x coordinates and just change all those coordinates, keep the y coordinates the same. Or maybe you prefer to just to graph it and draw your line of reflection and figure out where those go. It's just another strategy in your tool belt that you can use. And finally, we take a look at how to rotate. Like I said, we've figured out you can rotate using your compass and protractor or using those rotation rules. Here I'll show you how we can use our rotation matrix. So first of all, we need to figure out what the matrix is. Well, the rotation matrices, in a 180 rotation, we know the x and y's become opposites. So it would be negative 1, 0, 0, negative 1. With a 90-degree rotation, I'll just list those here in case you want those. We know that the y, xy, becomes opposite yx. So here we're taking the y and making it opposite, bring it to the x coordinate, and the x goes to the back. So it would be 1, 0. 270 is kind of the reverse of that. xy becomes y opposite x. So we'll have 0, 1, negative 1, 0. So in case you want to use the matrices for the rotations, that's what those are, and this is the 180. So we would multiply that out. Negative 1 times negative 1 is 1. 0 times negative 3 is 0, so we add that up, we get 1. Negative 1 times that is 0. 0 times that is 0. So basically what we're doing is just making this x the opposite. And then the same with the y. 0 times negative 1 is 0. Negative 1 times negative 3 is 3. Move over to the next column. 0 times 0. Negative 1 times 1 is negative 1. 0 times 4 is 0. Negative 1 times 0 is 0. 0 times 4 is 0. Negative 1 times negative 5 is positive 5. So notice all the coordinates just flipped around. And as we graph that, we can see what happens. So -1, -3 is W, 0, 1 is U, 4, 0 is D, and 4, -5 is E. So this would be W prime, U prime, D prime, and E prime. So know that we could graph those just by following what we know about 180-degree rotations. Just goes through the origin, forming a 180-degree angle. All the points go the same distance. Or we could apply any of our rotation rules or matrix rotations, multiplications. So this signals the end of our semester 1 unit review. Feel free to go back and check any of the problems that you need extra help with. If you need more of an explanation, feel free to see me in class. Or if you're preparing for the final exam, send me an email or put a note on Google Classroom. Enjoy your studies and have fun on that exam. I know I will.